Hi, I'm John Iwasz. I'm the CTO at Whetstone Technologies, and today I'll be talking about hosting an enterprise-ready voice solution. I've been in software for, over 30 years. 12 of those were spent at Microsoft, where I was in Microsoft Consulting Services, and I traveled around the country delivering solutions to large organizations and businesses, to enterprise clients, to the federal government. And I've spent the last 3 years creating and delivering voice user experiences. And today I'll talk about how some of those lessons that I learned delivering to global customers applies to voice UX and voice applications. But first, we'll need to define what constitutes an enterprise scale application. Well, of course, it needs to be stable, right? If you make a call to an API endpoint, you expect that call to be returned within a short period of time. It needs to be scalable. If your voice application suddenly becomes popular, you need to be able to scale and meet that demand and that surge in volume of requests. And of course, it needs to be secure, and that's a loaded term. Not just talking about securing the personal data and securing access, but also implementing secure policies. And I'll get into that a bit later. But let's look at what a typical voice application is comprised of, right? So if you're like me, you've may have created a voice UX experience and started with a tutorial. I know that's where I started, with the Alexa cat fax demo. And it's a simple use case. It's enough to get familiar with the development environment and creating a natural language model. But the application is fairly simple, right? You have a set of cat fax that's expressed in an array that's embedded in the code. There's no back-end integration. There's no need to collect any personal data. You ask for a cat fax, you get one at random, and then it asks you if you would like another one. There's no need to maintain state. There's no need to maintain any data after the session ends. There's no collection of private information. And so no privacy statement is necessary. But that's significantly different than a more complicated and arguably more useful scenario of getting food delivered or ordering a pizza. There are multiple components involved there that quickly become much more complicated than the simple cat fact example. In order to get the food delivered, you need to register an account with the restaurant or food chain that you're ordering from and have a credit card on file. So you've got account linking involved. You have a multi-turn conversation asking you what menu item you would like, if it happens to be a pizza, what toppings you would like on the pizza. There's data storage of not just your order, but your address. The restaurant needs to know where to send the order to. There's a financial transaction involved. The user, at the end of the order, confirms the order and then grants agreements to pay for the order. And any platform that is used to surface this application, whether it be Alexa or Google, Samsung, Bixby, you're going to need to publish a privacy statement that tells the consumer what personal information you're storing and why you're storing it. So let's look at some of the layers of that voice application that makes it different than, say, a traditional enterprise line of business application or public-facing application like insurance processing, right? If you're a developer, no doubt you've created a website. There's a user experience involved. There's an interface involved. Well, voice applications, of course, have the voice as the interface. You have a natural language processing engine, a natural language model, natural language generation for the responses that are sent, whether they be text to speech, whether it's or SSML. The response of the voice application needs to meet customer expectations. Customers can speak more quickly than they can type. And so the response needs to feel more conversational. So your backend system needs to be responsive. And of course, underlying all of this, which is common to enterprise applications, you need to account for data security and regulatory compliance. So let's dive into these two scenarios a little bit more deeply. In the cat fact example, if you ask for a cat fact, and in the tutorial, certainly you've got an array of cat facts that's embedded in code, but that could be abstracted out to a data store, and then the answer is provided through Dialogflow response, an Alexa response, a Samsung Bixby response, and eventually that endpoint, that device that's sitting on the user's in the user's living room at home does the text-to-speech translation or SSML to speech translation. And there's not a whole lot behind that. There's no back-end integration. There's, again, no need to store data. Parsing out the requirements of this food ordering application, we have customer information. Right? You have the customer's name, their credit card, their home address. They make a menu selection. So you've got content management involved. Somewhere under the hood of this voice application, you have a content management system that allows the restaurant to update their menu and make it available online through multiple mediums. Maybe they have, certainly I would expect them to have a website, maybe a mobile app, and now a voice application. You have payment processing integration. And you need to be able to inform the user when the delivery is expected. So what's the preparation time? And then finally, once the order is placed, keep them up to date. Let them know when that order has left the building and is now with a delivery driver on the way to their home. And that could be through maybe SMS text messaging, maybe through a mobile push. As an end user, speaking for myself, I don't feel that the voice application should end with the voice experience. It is a voice first experience, but not necessarily voice exclusive. So you may find situations like this where you capture and initiate the user's interaction with a voice application, but continue the conversation through other mediums. In this case, when notifying the user of the order status updates, maybe it's not through push notification on the smart speaker, maybe it's through SMS text messaging, or maybe it's through push through a mobile application or a website update. And again, people talk faster than they type. So the application needs to be responsive. And as you can see here with the food ordering example, you may have multiple different backend systems that you need to coordinate with. The user shouldn't care or be aware of that, but your application still needs to be just as responsive as that simple cat fax example. So now we're getting into some regulatory compliance concerns. And the laws covering data privacy are different certainly between countries, between states in the US. In Europe, you have the General Data Protection Regulations, the GDPR. In the US, in California, you have the California Consumer Privacy Rights Act, which became effective as of January 1st of this year. And coming in November, there's an addendum, the California Privacy Rights Act, that's going to be voted on that could further define and refine what constitutes private data and private information. You have HIPAA, the Health Insurance Portability and Accountability Act, that applies to healthcare related data. If you do choose to communicate with the user over SMS text messaging, there's the Telephone Consumer Protection Act, the TCPA, that stipulates you have to get the user's consent before sending a text message. They must actively opt in, and you must record and preserve their agreement and their consent. If you're dealing with any financial data, if you're dealing with a bank or a lender, there's FISMA, the Federal Information Security Management Act, and there's plenty more depending on what industry you belong to. If you happen to work for an organization that issues mortgages, there's the Truth in Lending Act, and the list goes on. You've got different groups of people that are treated, whose data may be more sensitive than others, like children and senior citizens. For example, Amazon has different policies for skills that target children than skills that are designed for adults. And it would be helpful to define exactly what does constitute private data. We have PII, that's any data that can be used to identify an individual, like social security number, an email address, a phone number is considered PII. You have PHI, protected health information, that's any information in a medical record that can be used to ID an individual. And that would include like MRI scans, blood test results, and specific phone records, phone calls to a doctor's office specifically. And there's device identifiable data. And that's any data that's linked to a particular browser or device, like an IP address, browser cookies. In the case of Echo and Alexa, Alexa requests include the device ID of the Echo device the user is interacting with under the context system device JSON block. And there's GPS data, which depending on the context could fall under any one of these. And you've got cybersecurity frameworks that are designed to bring some level of standards to handling your internal environment, data collection, the transmission of data. Here is an attempt at creating rules and regulations that would apply to a specific industry or cross-cutting across all industries. For example, there's the NIST standards that define things like password security and password reset policies. NIST is defined by the defined by the government, by the U.S. government, and if you do have a contract with the federal government, chances are that your business needs to comply with NIST standards. There's SOC 2, Service and Organization Controls, which is a common standard that a lot of vendors will accept if you wish to do business with a large organization. SOC 2 compliance is something to consider. That's a widely accepted and respected standard. There's high trust certification if you wish to do business with a what's considered by HIPAA a covered entity. That's any organization that provides healthcare services like a hospital, a doctor's office, an insurance provider. And by the way, these certifications are lengthy, they're time consuming, they're expensive. So you want to consider which route you go down very carefully. There's the payment card industry data security standards. Try saying that one 10 times fast. It's specifically targeting the processing of credit cards and credit card related data. So if you happen to have to accept a payment and you're not directly involved in payment processing, you know, you're not PayPal, you're not Citibank, you're not a bank, you're better off letting some third-party integrator take care of that for you, so you can redirect to another payment site and then redirect back to your organization. So you don't even touch the credit card. It's one less piece of data that you would need to encrypt and manage. And there are many more. There's ISO standards, and again, the list does go on. So how do you navigate this? How do you figure out which standard that you need to apply? It's a lot to digest, and if you have any insomnia, I'd recommend reading through any of these compliance standards. It'll cure you very quickly. So you don't want to just pick one at random. You want to ask the right questions. So consider which industry you're targeting, or which businesses your organization is targeting, and consider which regulations apply to that industry and let that guide you. You know, if you're in finance, FISMA may make sense, SOC 2 may make sense. What are the platform policies on the voice platforms you're targeting? What are Google's policies, Alexa's and Samsung's? It's worth reading through those before you publish a voice application. And this one sounds rather obvious, but it's easy to overlook. What do your customers want? What are they asking for? In many cases, your customer will tell you which cybersecurity framework they prefer or which ones they accept. And of course, I'm not a lawyer. I don't dispense any legal advice. Certainly consult with a lawyer on these topics when you are selecting and coming up with a framework and a privacy policy. But do consult with your legal department or consult with a lawyer. When you do engage with a large customer, you can expect to receive a vendor questionnaire, which is their way of vetting you. Even if you don't necessarily apply a cybersecurity framework, there are some common questions that apply that every vendor is going to ask you before they do business with you. Like, does your company have an established compliance program for assessing and manage data privacy risk? Consider that one for a moment. Does your company have an established compliance program for assessing and managing data privacy risks? So that's beyond the technology implementation. That's beyond just, you know, encrypting the data. That involves having a well-established policy and process for assessing data privacy risk, addressing it and remediating it, and monitoring for data breaches. That's quite a loaded question. And the answer to that is not just about the technology, it's about the policies that you enact, as well as the training that you give to your employees. Does your compliance program include assurance mechanisms like monitoring and auditing of the data privacy controls? Do you have active monitoring in place for intrusion detection and for reporting that intrusion detection? And what's your policy for notifying your customer if there is a data breach? And again, the list does go on. But there are some common themes across these cybersecurity frameworks. So irrespective of which framework you follow, whether it's NIST, whether it's SOC 2, there's some general practices that apply across the board, like encrypting, or rather applying least privilege security principles. Like only grant access if access is required, right? If you have a developer that is working on a new release, they don't necessarily need access to the production system. You should have a production team that's responsible for deploying, ideally, if it's not automated and completely automated, certainly limit access to your production environment. Understand what needs to be logged and what to avoid logging, which gets back to PII. So you don't want to log, passwords, right, in your application logs. You don't want to log personal information like phone numbers in application logs. Don't make it, if somebody does breach your firewall, you don't want to make it easy for them to get at customer data. Application logs typically are not encrypted. Don't store anything that should be encrypted in those application logs. Only collect the personal data that's necessary, right? Consider the business requirements for the solution that you're developing, and only get the personal data that's needed. For example, with Twilio, you can find out more information about an individual based on their phone number. With a couple of calls to Twilio's API, you can find out what phone service they use, whether it's AT&T or Verizon. You can also find the name of the person that phone number is registered to. But is that really necessary just to deliver a text message, right? So only collect what's needed to accomplish your goal. It reduces your potential exposure. Purge the data when it's no longer needed. Like the TCPA requires that you capture consent to receive text messages. That consent needs to be maintained for 2 years. At the conclusion of those 2 years, purge that data. It reduces your risk in a data breach if you have less data to expose. HIPAA requires that any access to health-related information is recorded. Who accessed it? Why are they accessing it? The same applies for any financial data. If I'm accessing somebody's bank account, I better have a good reason for accessing that account. And there should be an audit capture that records my access of that financial data, that healthcare data, or that sensitive data. Monitor for security breaches, like you want to do intrusion detection. If somebody does breach your firewall or pings a port repeatedly, you want to be notified of that and maybe shut down that IP address. There are services on cloud providers to allow for that, like GuardDuty on AWS, and on Azure you have advanced threat protection. Make use of those, and also take a look at what other third parties provide more comprehensive monitoring services. And it sounds like it goes without saying, but encrypt your private data, both at rest and in transit. Of course, whenever it leaves your enterprise, whenever you're sending data to a customer or sending data to a business partner, but also internally. So if you're sending a request to dispatch a message into a queue, for example, and you need to dispatch a text, an SMS text message, and that queue message must contain a phone number. Encrypt that data inside the queue as well. It's not necessarily something that you expect to send, outside your system. But again, if you have a data breach, don't make it easy for the bad guy to get at your data or your customer's data. Train your employees on your policies. If there is a data breach, they should know what to do. And they should also know to take actions to avoid common threats like email phishing attacks. Monitor your application availability, right? We're all familiar with a ping request. And it's common practice on whenever you publish an API to have kind of a health check endpoint that tells you that that API is still active, it's still working. Do the same for your voice applications, for whether it be supported through a Lambda endpoint or whether it be supported through a REST API. Execute those health checks and make sure that your application is still working, still responding. And even if it is responding, it may not be responding as fast as you expect. So you want to set up some alarms that, well, if an API call takes more than, let's say 4 seconds, you register an alert and notify responsible parties of missed targets. Have that alert be sent through email or a text message to the people that are responsible for production support. Keep your environments separate, right? I mentioned that developer that's working on your release that's checking in code should not have direct access to your production environment. And it's certainly not my favorite task. And I wouldn't expect developers to jump at the chance to write documentation, but it is necessary when you're complying with these cybersecurity frameworks to document your security policies, and your architecture, and how you monitor for data breaches, how you monitor for intrusion detection, and how you isolate it, how you report it, and have a general architecture overview document, not just to onboard new employees and onboard new developers, but complying with frameworks like SOC 2 and NIST are going to require it. And again, these cybersecurity frameworks do go just beyond the technology. Like, for example, for SOC compliance, if you have a physical office, you have to have cameras that monitor that physical office space. Any visitors need to sign in a logbook that shows when they arrived and who they're there to see. So, when you do consider which cybersecurity framework to apply, it does go beyond the technology. There are third-party services that you can deploy into your cloud environment that will search for violations of certain rules, like NIST, like SOC 2, and bring them to your attention. I've used them and have found them to be helpful. They are expensive, and if you do engage with a third party to do more fine-tuned monitoring and not just guard duty or active threat detection, but you do engage with a third party to do specific detection for a specific cybersecurity framework like NIST or SOC, make sure you know which cybersecurity framework you want to apply. The pricing model and the technology does vary depending on which framework you're applying. So we've done a bit of a deeper dive into some of the actions that you can take to enable your voice application to be enterprise ready, to be scalable, right? You're monitoring for responsiveness. You should, of course, do your load testing and ensure the application can scale. And we've talked about the cybersecurity frameworks, what does constitute private data. We've talked about engaging with third-party auditors, like, for example, with SOC 2 compliance. you must engage with a third-party auditor that that will certify that you are SOC compliant. There are, third-party security validation tools you can use, like OWASP, OWASP ZAP, which usually is used to test security of a website, but they do have capabilities to test an API as well for some of the common API vulnerabilities. You can use third-party tools for cloud monitoring. Like, for example, at Whetstone, we use Bespoken specifically for doing monitoring of our voice applications, and to ensure that not just the backend API is responsive, but that the skill or Google Action is responsive from the platform. Because if we have, for example, you could have an issue in your network that sits between, say, your Alexa skill and your REST API endpoint. So if you just ping your REST API, it'll tell you whether the REST API is working or not. But if there's a network issue between the two, you need something there to account for it. There are tools for doing active and passive code scans, like HP Fortify. You can engage with white hat hackers to perform penetration testing. Of course, these do come with an expense. So when you do decide to test, when you do apply the framework, your chosen cybersecurity framework, make sure you have a target in mind. Make sure you have an end goal. And lastly, you can reach me on LinkedIn, on Twitter, my email address, and we also have a skill out on Alexa or Google. You can say, open Whetstone Technologies or talk to Whetstone Technologies. Thanks for your attention, and I look forward to hearing from you.